Good day, everyone. Today we will be talking about the Pappus theorem for surface area. So by definition, it lets us find the volume using the centroid and an integral. So V is the volume of the three-dimensional object. A is the area of the two-dimensional figure being revolved, and D is the distance traveled by the centroid of the two-dimensional figure. So specifically in the Pappus theorem of the surface area, actually this video will discuss about its theorem for surface area and theorem for its volume or the solid of revolution. So let's talk about the surface area first. Surface area for the Pappus theorem is, the formula would be surface area is equal to 2 pi r times the length of the arc. So S is the length of the curve, okay? And R is from the centroid, distance on which axis you will rotate. So R is the distance on which axis you will rotate from the centroid. So let's say, for example, you have this curve, okay? So that curve has the center somewhere here that we do not know. For example, we're going to rotate at the x-axis, so y-axis. So our length of the curve is the length of this, so that's the S. Okay, and R nato here would be this one. So from the center, and then the distance on which axis you will rotate. So in this case, you will rotate at y-axis. So your R is equal to x. Ayan. So let's have an example. To determine the surface area by revolving the y-axis, the portion of the curve x squared is equal to 4 plus y squared from y is equal to 0 to y is equal to 4. So this problem, we have been already taught, or we have been already acquainted to the conic sections, and with that, we can easily determine that this equation is hyperbola. So hyperbola has this equation, x squared over a squared plus y squared over b squared is equal to 1. So how are we going to change that into the standard form? Okay, let's do that. So you have x squared minus y squared is equal to 4. Divide everything with 4, so you have x squared over 4 minus y squared over 4 is equal to 1. So we cannot say that this is an ellipse because an ellipse should have a bigger a or bigger b. Because kung whichever the number is greater, okay, mo to siya ang, that will be the palatandaan, what's this English? That will be the basis that our ellipse, or which axis our ellipse will elongate. For example, bigger CA, so it will elongate at x-axis. So if bigger CB, it will elongate at the y-axis. So please review those conic sections. Okay, so we have A as 2. Okay, this is A, and B is 2. Okay, so the formula for ellipse is x squared over a squared, always a squared, ang ilalom, minus y squared over b squared is equal to 1. Okay, so we already have A and B, so therefore we can easily graph this. So 1, 2, this is A, 1, 2, 1, 2, 1, 2. So it's somewhat like this. Okay, but we only are going to satisfy the equations, or we are going to get the surface area from 0 to 4 lang. So y is equal to 0 to 4. Okay. So therefore, this is only the surface area that we are going to get. Okay. So by the formula SA is equal to 2 pi rs. S would be the length of this arc, this portion here. So to get that, we have this equation x squared is equal to 4 plus y squared. So to change that form, that's x is equal to 4 plus y squared square root. And remember in our previous lesson, to get the arc length or the length of the curve, you have this formula s is equal to square root of 1 plus dx over dy squared dy. Now we are going to use this. We're going to use dy since we already have the limits of 0 and 4. Okay? Ang atong limits na is 0 and 4, so it's very convenient for us to use dy. So we are going to get dx over dy first. So what's dx over dy of this? So this is 1 half times 4 plus y squared to the power of negative 1 half times 2y. Cancel, cancel. So our dx over dy is just equivalent to y over 4 plus y squared square root. So what's next is we are going to put this into this equation to get the surface area. So that is 2 pi. And then what is our radius? Again, our radius is from the centroid from uh, the centroid to where the axis will rotate. So for this, it will revolve at around y-axis. So this is r here, which is equivalent to x. Therefore, we can now say that from 0 to 4, then 2 pi, then our radius is x, square root of 1, or dx over dy is 1 plus y over 4 plus y squared. Then this is square root, then squared dy. Now take note that we cannot substitute this one yet, since um, this is x and we are integrating in terms of y. So what are we going to do here is that we will change this equation first into x squared is equal to 4 plus y squared. So therefore, that will now be equal to 2 pi from 0 to 4. Oh, sorry. From 0 to 4. So this should be equal to the square root, x is the square root of 4 plus y squared multiplied by the square root of 1 plus y over 1 plus 4 plus y squared square root dy. So class, since this is very time consuming and we've already demonstrated to integrate in our previous lessons, you can use your calculators to integrate this one. So that's 2 pi 0 to 4. Input it in your calculators. Then square root of 4 plus y squared or x squared multiplied by the square root of 1 plus x over square root of 4 plus x squared. So why am I using x, since the calculator is just integrating in terms of x. So you just change y into x. Okay, So the surface area is just equivalent to, sorry, squared pala to. So it's equivalent to 90 squared ini. 91, yun, 91.0616 square units. Okay, so that's your surface area for that problem. For problem number 2, determine the surface area generated of the line segment intercepted by the coordinate axis is revolved about the y-axis. So assume that the equation of the line is 3x plus 4y minus 12 equals 0. So we have this graph 3x plus 4y minus 12. So you can use your calculators to graph that one. Okay, to graph that one, use tables and then ilagay nyo yung equation. So that's 4y is equal to 12 minus 3x and then divide by 4. So that's the equation that you're going to input and then you're going to set values. Okay, so to graph that one, we can actually form a line, of course. So in that line, this is 0, 3, and this is 4, 0. So actually, we can use analytic geometry to solve this problem. Okay, let's compare if we're going to use analytic geometry, same ba siya if we use the Pappus theorem. Using analytic geometry, we are going to get the center for this. It's just the midpoint, no? The midpoint. So to get the midpoint for that, so that's 0. So x at 0 plus 4 divided 2. Then si y is 3 plus 0 over 2. So our midpoint is just at 2 and 1.5. So therefore, this is 2, 1.5. Okay. And then, we are going to get the length of this line. No? The length of this. So, how are we going to find the length for that one? Simple. We just use the distance formula from this point to this point. So the distance is s is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So therefore that is s is equal to square root of 0 minus 4 squared plus 3 minus 0 squared. So dapat your s is negative 4, 16 plus 9 square root of 25, that is 5 units. So that's the length. Okay, now we have the midpoint, we have the s, so surface area is equal to 2 pi r s. Okay, the only thing or the only problem here is we do not have yet the r. So again, we will revolve at the y-axis. So from the centroid to the center of rotation, to the where it will rotate. So that is r. Again, it's just equivalent to x. So since the problem is just saying it generated to the line segment intercepted only by the coordinate axis, we're just going to find this, no? Intercepted by the coordinate axis lang man, x and y. So this portion here. Yan. Okay. Let's go back to red. So our r is, how are we going to get r? Remember class that we have this in analytic geometry, we have this what we call distance from this point to a line. And this line here, kani siya na line, is just x is equal to 0. Right? So, the formula for the distance from a point to a line, remember that that is ax plus by plus c over the square root of a squared plus b squared. Okay? So that's is equal to our a. Okay, our a is, saan na to? Tama ba ni x to 1.5? Okay, tama. So, okay. So, this is ax. So, our, from x is equal to 0, so x plus 0 plus 0 is equal to 0. So, ano lang siya, no? So, we only have a, which is 1, 0 si b, and 0 si c. So, therefore, this is 1 times our x is 2, our b is 0, our y is 1.5, our c is 0 still, all over the square root of a is 1 plus b is 0. So therefore, you will get r as 2 over 1. So that's 2. Okay, so we have r is equal to 2. Now we can find the surface area as 2 pi rs. So that's 2 pi times 2 times s is 5. So therefore, that's 10 times 2. It's 20 pi square units. Okay, now let's use the Pappus theorem method to solve for this kind of problem. So let's erase. So dapat ang atong answer is still 20 pi square units. Okay. Okay. So again, to get that one using Pappus theorem, still the same formula as a is equal to 2 pi rs. Okay, so just get the length of the curve, diba? So that's integral of a to b, then square root of 1 plus dy, or vice versa, no? It's up to you because we have the limits x and y. So karon atong gamiton na limit is x. So from 0 to 4. Diba? 0 to 4, 1 plus, unsa ang dy over dx? So 3x plus 4y. So 4y equals 12 minus 3x. So divide by 4 rather. Divide by 4. So y equals 3 minus 3/4 x. Or dy over dx is negative 3/4. So that's 1 plus negative 3/4 squared dx. Okay, we can put that here. So SA is equal to 2 pi from 0 to 4. Okay, we do not have r yet. So our r is just x, no? And what is our x? Oh, x. Okay, in terms of x, manday siya. So that's x. Then multiplied by the square root of 1 plus negative 3/4 squared dx. Okay, so therefore you have the surface area as dapat 20 pi Japon when we input that in our calculators. So that's 2 pi, 2 pi, then integral of 0 to 4 x times square root of 1 plus negative 3/4 squared Our answer should be 20 pi. Yes. Still 20 pi. Okay. Sir, what if I will use this one? Surface area is equal to from A to B 1 plus dx over dy. Okay, no problem. Sige. So, let's change this equation here. Change that one into 3x is equal to 12 minus 4y. So divide both sides by 3. X is equal to 4 minus 4 thirds y. So dx over dy, so x with respect to y. So that's negative 4 thirds. Nalang kasimple. So surface area is equal to, okay, our r here is x. So dapat that is 4 minus 4 thirds y. So this is 2 pi. And then our limits is now from 0 to 3. From 0 to 3, then r nato is x, which is 4 minus 4 thirds y. And then the square root of 1 plus negative 4 thirds squared dy. So dapat, if we input this in our calculator, the result would still be 20 pi. Oops, 4 minus 4 thirds. Yx. 1 plus negative 4 thirds. Let's see. 2 pi. 4 minus 4 third. 1 plus negative 4 thirds squared dx. Okay, hold on. Tama, 0 to 3. Dapat 20 pi. 0 to 3. Ay, kadugay. Ayun. 20 pi square units. So, if you solve either ways, you will still get the same result. So, let's now go for the Pappus theorem for solid of revolution. So, in this topic, no, we are going to get the volume. It is a Pappus theorem. And, sir, nganong kinahanglan pa man si Pappus theorem? And why not the other one? So, Pappus invented this formula with the use of centroids. No? Kaya gani, di ba, earlier by definition, find the volume using the centroid, no, and an integral. So, dili na to siya makuha if dili ta kabalo unsaon, or if you're not able to know how to solve for the centroid. So, review our previous lesson. So, volume is equal to 2 pi RA, where A is the area of rotation and R is the center of rotation. So, example, we are going to determine the volume generated by rotating the curve 9x squared plus 4y squared is equal to 36 about the line 3x plus 4y is equal to 20. Okay, so we are going to graph this one first. So 9x squared plus 4y squared is equal to 36. So kani siya, sige, I'm sure that this is one of the conic sections. but I don't know yet which one. Okay, let's try to divide all by 36. So 9 over 36, it's x squared over 4 plus y squared over 9 is equal to 1. Okay, this is obviously an ellipse. 1 elongates, and it's in the y-axis. So therefore, this is our A is 2, B is 3. So 1, 2, 3, 1, 2, 1, 2, 1, 2, 3. So somewhat like this. Ayan. Okay. So what about 3x plus 4 equals 20? So 3x plus 4 is equal to 20 is just a line somewhere here. Yeah. Okay. So determine the volume by rotating the curve. Okay, rotate this curve about the line 3x plus 4y. Okay. So we have volume is equal to 2 pi RA. Okay. We have some unknown problems. Oh, actually, again, this can be solved with the use of analytic geometry. So, for example, in cases like pinaka-importante yun ang board exams, right? Or other exams like MCQs and you have limited time. This can actually again be solved with the use of analytic geometry. We all know that the formula of ellipse is the formula of the volume of the ellipse is just, or the area rather of ellipse is just pi times a times b. That's pi times a is 2, b is 3. So that's 6 pi ang area. So we have area and we do not have r. Again, r is the from the centroid to where it will rotate. No? So rotating the curve, so here mag-rotate. So this is our r. No? Rotating so si curve da ay mag-rotate diri na line. Sorry, ana di siya. So from this to this is our r. So therefore, volume so unsa ang atong r from this point to this point. So that's point to distance from a point to a line with the same formula that we have used earlier. So it's just okay. So we have 3x plus 4y equals 20, diba? And we have this as 0, 0. No? So kani man ang center, di ba? Centroid ani, center aning ellipse, and then rotate the curve about this line. So diri mag-rotate. No. So from this center to the center of rotation, is our r. So from this point, which is 0, 0, to this line, 3x plus 4 equals 20. So that's 3 times 0 plus 4 times 0 minus 20 all over 0 plus 0. Ay, sorry, a is 3 squared plus b is 4. So therefore, we can get the r as 4. Okay, so volume is equal to 2 pi, where I have area, yes, 6 pi. So 2 pi times 4 times 6 pi. So that is 48 pi. Ay, squared. Ano ba? 24, 48 pi squared. Cubic units. Okay? So that's your volume. Okay. Kanang challenging daw gamay, sir. So what if kanang solvable, dili siya solvable with the use of analytic geometry. So determine the volume bounded by y squared is equal to 9x. X is equal to 2 about the x-axis. So for this type of problem, obviously, So di man ni wa man kay line, di man ka pwede maka-distance from point to a line because this one right here, y squared is equal to 9x is just or is a curve na yun ani. So then x is equal to 2 is 1, 2. So for example, this is 2 na. Okay, and where are you going to rotate? At x-axis. So here is our axis of rotation. So from this point, which is the centroid, to this point is our r. Okay, we can actually solve this one using the horizontal or the vertical strip. Let's use the horizontal strip first to solve for this problem. And then later on, let's use the vertical strip. So this is r. So this is the center. So r. Okay, that's dy. Then remember that volume is equal to 2 pi r a. Okay, so our r here again, tanaw ang r, no? Ang atong r is ang y bar. Y bar man ni, no? Y bar nato sa ato ang uh, centroid. Centroid. So, unsa ganitong formula? What formula did we use to get the y bar here? Okay, we have already done this lecture. So again, let's refresh. So y bar is just equivalent to 1 over the total area. Then integral from a to b. Then this is y, then differential area, which is just equivalent to a to b, 1 over a. So y times differential area is xr minus xl dy. Okay? So therefore, you can get the volume because area is makancel siya na tanawa. Volume equals 2 pi. Okay? Then integral of, okay, what's the limit here? So to get the limits, y squared is equal to 9x. Y squared is equal to 9 times 2, it's 18, tama? Okay. Okay, sorry, this should be 8x. Okay, my bad. Tingnan ko bungkig man. Okay, y squared is equal to 8x. This is y squared is equal to 8x. And this is x is equal to 2. So, dapat 16 lang na siya. So, y squared equals 16. Actually, pareha lang yapon na pero para dili kay siya libog i-lecture. Dapat ano siya, y squared equals to 16 so that y is positive, negative 4. So, obviously, this is 0. Then this is 4. No? Then, so ano siya? 2, negative 4. 2, positive 4. Okay? So, nanatay limits. Since gamit nato is dy, so that's from 0 to 4. Then, our y is y. Then, xr is 2 minus xl, which is 8x. Oh, no. In terms of y. So, y squared is equal to 8x. So, this should be yan, x. So, that's y squared over 8. Sorry. Y squared over 8. Ayan. Then, dy. So, asa naman si ku answer? Nawala lagi ang area. Okay, times 1 over a pa man no. 2 pi ra man na. Multiply pa ni mog a. Cancel, cancel. So, that is cancelled. So, we can integrate this one very easily na, no? 2y minus y cubed over 8 dy. So, volume equals 2 pi. Again, you can use your calculators. I don't care. So, that's 2y squared over 2. So, y squared minus y4 over 32 from 0 to 4. So, that is volume is equal to 2 pi. 4 squared is 16 minus 4 to the power of 4 over 32. 4 to the power 4 over 32 is 8. Minus 0 minus 0. So therefore, that's volume is equal to 2 pi. 16 minus 8 is 8. 16 pi cubic units. Yan. Alright. So, what if we use the vertical strip? Okay. So, can we erase? So, for vertical strip, hold on. Erase ta, no? Vertical strip. So, again, y squared is equal to ax na siya. Pasensya. Okay, and then this one pa din. Vertical strip. Ayan. So, this one. Create tayo ng strip. Vertically. Ayan. So again, still, we are going to rotate at the x-axis. So our our radius is just pretty much the same. So from the centroid, this which is that one, to the axis of rotation, which is the x-axis. Okay, so just r is still equivalent to y bar. So kaganina nakuha na to ang points of intersection, so 0, 0. So this will now be from 0 to 2. Okay, so y bar is just equivalent to, again, atong strip is dx naman na siya. So, diba ano na siya, 80 total area y bar is equal to integral of from a to b. Kuha na to ang, diba, centroid ni. We are going to get the midpoint or the center. So that's xr plus xl, y upper plus y lower all over 2. Then the differential area, which is y upper minus y lower dx. Okay, so divide both sides by 80. So therefore, that's 1 over 80 times that one. Then igawas na to si 2, padulong diri. So that's y bar is equal to 1 over 280 from a to b, y upper squared minus y lower squared dx. So, nanatay y bar, then ang formula is 2 pi r, ito, 2 pi ra. Okay, so, ang area is useless diri. Kay tanawa. Why? So, volume is equal to from 0 to 2, since we are using the limits in terms of x. 1 over 280, then times 2 pi pa man, times 2 pi na. So, makancel si 2. So, mabilin, pi over area. So, 2 pi times the radius, which is y upper squared minus y lower squared, times dx, times the area, which is this one. So, cancel the area. So, what's left is just pi. From 0 to 2, what's our y upper? Y upper is 8x. Y lower is 0. Square root of 8x minus 0. Kasi y squared is equal to 8x. Square root, y is equal to the square root of 8x. So, square root of 8x dx. And then squared pa man ni, no? So, volume is equal to pi from 0 to 2. That's 8x minus 0 dx. Okay. So, volume is equal to pi. So, mawala si a. So, may mo siya og From 0 to 2, 8x squared over 2. So that's 8x squared over 2. 4x squared from 0 to 2. So that's pi times 4 times 2 squared minus 0. So that's 4 times 4, that's 16 pi cubic units. So did we get the same answer earlier? I think we did. So that's for the Pappus theorem of solids of revolution. So guys, if you have any questions, we will have synchronous sessions to cater your questions. Thank you so much for listening. Have a very great day.